This is actually a report. The Jadot report is produced after the demonstration or demo day 1, and again after demo day 2, and compares the measured values of the various parameters against the predicted ones, which we know for a fact are safe. So the technical teams in the 3 control centers review this report and discuss what we call gray areas, where we're not quite sure. We think we're meeting the criteria, but there could be some doubt. So those things are discussed in great detail, first of all by the various technical teams, and secondly by the 3 flight directors in the 3 different centers. And finally it comes to the ISS mission management team for a decision on the go-ahead. Now, we have simulated this in some detail in order to prove that it works, and we've even got this bunch of managers here to participate in that and give us a bit of training to make sure that we can make the right decisions on the day. Let me say a little bit more about the various phases of the mission. First of all, launch and early orbit operations, or LEOP as we call it. During this phase, the ATV is switched on and the propulsion system is primed, the solar arrays are deployed, and we start the GPS, which provides the navigation in the first phase. Then we go into a phasing which has a minimum duration of 10 days in order to catch up with the station. During phasing, we perform a set of orbital maneuvers prepared by the ATV control center to bring the ATV to a point approximately 39 kilometers behind the ISS and about 5 kilometers below it. In this phase of phasing, we demonstrate the ATV's ability to control its attitude in both modes, yaw steering and earth pointing, as well as the ability to slew between the 2 attitude modes. We also demonstrate that the ATV has the ability to perform accurate orbit maneuvers, and to also demonstrate that in the control center we can do accurate navigation using GPS measurements from the ATV. However, from a safety point of view, the main objective in this phase is to demonstrate the ATV's ability to execute what we call the CAM maneuver, which is a collision avoidance maneuver, and this is one of the key means of ensuring safety of the ISS and its crew. If we go on to demo day 1, perhaps I could have chart number 8. Here we start and finish at this transition point of 39 kilometers behind the space station. And first we approach to a point 3.5 kilometers behind the ISS, at which point we perform an escape maneuver commanded by the control center, the ATV control center, and that's basically the end of the end of the demo day 1. That process takes about 4 hours, and after we perform the escape maneuver, there are a series of orbital maneuvers which take the ATV around the space station. It flies around the space station and back to the point 39 kilometers behind from where it started. Now, during demo day 1, we demonstrate that the ATV orbital maneuvers required to reach the various target points are safe with respect to the space station. We are also proving that the ATV relative GPS is the navigation using relative GPS is actually working correctly. That the flight control monitoring system, which is this means of checking independently that our prime navigation system is working, and that we can do an escape maneuver which will put us into a safe orbit with respect to the ISS. Let's go on to demo day 2. Demo day 2, like demo day 1, starts at this this 39 kilometer point behind the ISS. And first of all, we will approach to a point roughly 250 meters behind the ISS, and then we'll proceed towards the station from there. Shortly after that, we will demonstrate the capability of ATV to hold, resume, and retreat. These are maneuvers which we could require if things don't go correctly during the rendezvous proper. Having demonstrated that, we then approach. We then continue towards the station to a point roughly 12 meters away, and then retreat back again to a point about 20 meters away. And from there we perform another escape. This time it's commanded by the crew to prove that they have the capability to do this. And having done that, we continue the same cycle that we did on demo day 1. And retreat back to the 39 kilometer point behind the station. Now, that all sounds very complicated, but it's designed specifically to demonstrate some key features. First of all, that all the flight control monitoring system, this is the system which is checking that we're within limits, that all the success criteria are okay for that system. Secondly, that the videometer is producing data. This is the laser sensor that John described. That this is producing good data, and that it compares with the telegoniometer, which is providing the watchdog function for the videometer. We're also showing that during this demo day 2 that the ATV can perform force translations and relative attitude navigation during the final approach, and that is obviously a key feature for being able to go in for the final approach. And last but not least, we involve the crew at this time, and we're actually asking the crew to monitor this approach, and we will prove during demo day 2 that they can successfully do that. I'll say a little bit more about how the crew monitors the ATV in a minute. So after demo day 2, we will have demonstrated all the key features of the ATV with respect to its safety to approach the space station.